Hello, welcome to Business Statistics. In this lecture, I will talk about population and samples. Firstly, we will try to learn some of the terms that will be used in business statistics. Population, it's a set of all elements about which we are interested in making inferences. If we list out all the members of a population, it is called frame. If we survey all the elements of a population, it is called census. If we take a subset of a population and try to gain insights about the population, it is called sample. Facts about a population is called population parameter. Facts about a sample is called sample statistics. Descriptive statistic is a science of collecting, organizing, analyzing, and presenting of data. Inferential statistic is science of making reasonable estimates about population using a sample. So we use a sample to make inferences about population. It is called inferential statistic. So in this slide we will use a framework to understand the terms which we discussed in previous slide. So population, it's all elements. So this bigger set, this bigger or larger set is a population. So a population can be of two types: a finite population or an infinite population. Finite population, an example will be all students in statistics class. All students in statistics class. So if we have 40 students in statistics class, the population would be 40. An example of infinite population would be all residents in a city. So if we see in a city, the residents, the number of residents keeps on changing as people move in and move out. So it's not fixed. That's why we call it as an infinite population. So the facts about population is called population parameter. So if we wanted to measure the height of students in our statistics class, so one of the ways we can measure is average height. So what we can do is we can ask each of the students their height and key it in a spreadsheet and calculate the average height. Suppose the average height of the students in all the students in statistics class is 5'6". So this is our population parameter. So to reach this average height, we used a technique where we asked each of the students to tell their height. We collected the data and then we analyzed it to reach the average height. This technique is called descriptive statistics. So where we are describing what would be the average height, that's a kind of called descriptive statistics. So if we wanted to measure the height of residents in a city, it's a challenging task because the city might have 100,000 or 200,000 population. Measuring each one of them is a challenging task. In addition, if we put an effort to measure the average height of the city, by the time we get a value, the population might have changed because some people move in and some people move out. So that's the reason the height of the population would be also be changing, right? So that's the reason, one of the reasons why we don't want to work with the entire population. So one of the ways we can reduce our work is we can take a sample. So we can use a sample, we can capture certain random people from a population and ask their heights and form a sample. So suppose we take 100 residents and capture their heights. So we ask them the height of each of the residents, and we get an average height of 5'8". This is called sample statistic, because we took a sample statistic. So we took a sample and tried to analyze its what would be the average height. So this is the fact about a sample. So again, we used here, we took a sample and then asked each one of their height. The technique is again a descriptive statistic. So once we get an average height of 5.8, we are more interested in calculating the height of a population, that is the number of residents in a city. So one of the ways we can do is we can say, because we have 100 residents whose average height is 5.8, we can assume that the average height of the population would also be 5.8. So we can assume that the average height of the entire city would be 5.8. So this is, we are using a sample to make inferences about a population. That's why we call it as inferential statistic. So what we did is, especially with the residents in a city, we took a sample. So here is our population. We took a small sample and we tried to measure the height of the average height of the sample, which is 5.8, and then we said, okay, if the average height of 100 residents in a particular city is 5.8, the average height of that city would also be 5.8. So that's called inferential statistic, because we took a small sample of 100 residents and tried to make inference about the population. So this is how we use inferential statistic. So in this lecture, mostly if you see the facts, or some of the facts would be sample mean, sample standard deviation, and sample size. These will be the facts of a sample. And the population mean, population standard deviation, population size would be the population parameters. So these are few of them. We can also consider other facts like proportions, population proportions, sample proportions. We can use mean, median, mode. We can use variances. So there are a lot of them, but these are important because I wanted to highlight in this course, mostly sample are represented by English terms, whereas the population is represented by Greek terms. So this is important. Don't get confused between population mean and a sample mean. So a population mean is represented by mu, whereas sample mean is represented by x bar. Population standard deviation is represented by sigma. Sample standard deviation is represented by s. Population size is represented by capital N, and sample size is represented by small n. So this concludes our lecture on population and samples. Thank you.